Right. So yes, hello everyone. My name is Sergey Gribnyak, and we are starting our third and the last day of second IEEE Ukraine Distributed Ledger Technologies Forum. Here with me already our first speaker, so we are not having delays like we had yesterday. Gayan Benedict, who is the partner at PricewaterhouseCoopers, which is also one of the big four companies, and he also is a research fellow at MIT. Gayan, please feel free to introduce yourself, and the stage is yours.
Thank you, Serge, and hello everyone. I'm really pleased to be here. My name's Gayan Benedict. I'm an industry research fellow at MIT Sloan, the School of Management there. Also, as Serge mentioned, a partner at PwC. Before this, and I draw on this sort of experience in this presentation I'll share with you, I was the CTO for Salesforce in our region in Australia, New Zealand, and before then the CIO for our central bank, the Reserve Bank of Australia. And so I had a big emphasis or focus on resilience, particularly in my central bank role. And some of the thinking that went into this research came from that period of time. So I'm looking forward to this conversation. What I want to do is really share with you some of the lessons that myself and my research collaborators have experienced over the last several years looking at governance of ecosystems and how that works and how it doesn't work. And so we're looking at failure cases of governance across ecosystems and also success stories, and also some of our more recent research, which is extending that research on governance of ecosystems to the resilience of ecosystems, which hopefully will be of value and interest to you. So I wanted to share that some of those research insights with you. Just probably for context, my background in resilience is very much initially from an enterprise perspective for organizations, but obviously looking after the central bank technology for Australia, there was a big focus on ecosystem resilience, particularly the financial sector. And although resilience for organizations is challenging, achieving resilience across ecosystems much more challenging. And so obviously of relevance to yourselves in Ukraine in particular, and I'm fascinated if there's any questions on this topic as we go through the conversation. So the research outcomes I'm going to share with you based on a whole bunch of interviews we conducted over the last 2 years, including with some key folk involved in this conference from Ukraine, actually, across a large number of countries, like I said, including Ukraine, 21 different companies, some small, some not-for-profit organizations, some very small startups, ranging to organizations of over 400,000 individuals, and a broad range of leaders and accountable parties that we interviewed for this research as well. So I wanted to share here some of the thinking around why ecosystems are becoming more and more important. For many years, organizations were the key focus of economic activity, employment, new innovations. But over the last probably 10 or so years, particularly with digital innovation accelerated by COVID, digital transformation, we've seen an increasing amount of effort going into the development of digital ecosystems. And when we did the research, we were really interested to know why organizations putting more and more effort into their ecosystem solutions and the generation of value across ecosystems. And we came across three main reasons. The first on the left there is the opportunity to grow value. And we did a lot of case research in this study. One of the organizations we worked with was Bayer and their agricultural business in South America. And what we found was the opportunity to actually use an ecosystem to grow value beyond the traditional commercial relationships that an organization had. And so, Bayer in that case would sell fertilizer to farmers, and that was a very transactional relationship, and it was a source of revenue for Bayer. But they found an opportunity to create a digital ecosystem where more and more different participants were able to participate in that ecosystem, and then more participants who were able to contribute information, services, and products into the ecosystem there was actually an increased growth in economic activity for all participants. And so we find that the opportunity to grow value and create economic wealth was one of the reasons to encourage ecosystem participation, where you get more than two parties to actually contribute towards collective solutions. The second key motivation we found for ecosystem growth was the opportunity to address shared challenges and goals in a way that any individual organization was not able to address unilaterally. And so a good example of this, we used the case study of the new payments platform, the National Real-Time Payment Infrastructure established in Australia. The lack of real-time payments in the country was a source of inefficiency, lack of innovation, and it was also something that could not be solved by either the central bank alone or any individual bank. And so this challenge of having no real-time payments and the inefficiency caused by that was a challenge that was actually shared by all of the financial sector participants. And it was only by contributing and acting together as an ecosystem collaboration that shared challenge and goal could be addressed. And so we find this is often the case with shared problems like cybersecurity vulnerabilities, even climate change to a different extent. So these are problems which traditionally any one organization or maybe even two organizations can't solve bilaterally, but where a problem is shared across many parties, and the only way to really genuinely tackle the problem or achieve a goal that spans across an ecosystem is to actually collaborate as an ecosystem of participants. And so this was another apparent use case as to why ecosystem growth was developing, where there were these important societal or industry level challenges that hadn't been able to be solved unilaterally or bilaterally, and therefore multilateral solutions were really the only way to genuinely address those kind of challenges. And then from a distributed ledger perspective, we looked deep into the Web3 community and found that Web3 community in particular was a really good example of where ecosystems could come together, and participants in an ecosystem were able to find resources and expertise not otherwise available to them as an individual entity or organization, but which collectively as an ecosystem was accessible. And one of the examples we found quite fascinating was we researched with Wolfram Research, the makers of Wolfram Alpha, and we found that they were participating in the Cardano platform, putting up proposals and actually using successful proposals to actually fund the development of key AI capabilities for their platform. And so we found that was a really interesting example of ecosystems being a source of not just financial resources, but also expertise not otherwise available to an individual organization trying to address a problem. So these were some of the compelling reasons we found as to why ecosystem collaboration was increasing. So I often find it's one thing to talk about why things work, but it's always, I think, possibly even more interesting to find out why they don't work. And this was one of the key outcomes of the research, was to identify reasons for failed ecosystem collaborations. And I thought I'd share them with you in case they're of value. One of the things we found was that although value may be created across an ecosystem, we looked at some examples just previously, it's possible and often the case that value does not exceed the investment and the risk taken on by participants. And if that value is not seen or perceived to be greater than the risk or the investment required by any one participant, that can contribute to participants dropping out of participation in the ecosystem. And if enough participants withdraw from participation in the ecosystem, then the ecosystem collaboration itself will fail. Another key reason we found was if there was a particularly powerful participant within an ecosystem, potentially seeking to govern the broader ecosystem, maybe it was the organization or individual that initiated the ecosystem in the first place. If the participants did not trust the motivations or the actions of that particular governing party, that was another reason for ecosystem participants to withdraw their participation. And so that's something which we'll touch on in terms of a way of improving ecosystem collaboration shortly. We then looked at the other core issue that we found was that participants may find or perceive that the benefits that are becoming generated for an ecosystem are not being fairly distributed to them, that those benefits may be going to another party or maybe a governing party in a way which is unfairly distributed to them and against the participants. And so if there's an inadequate or a perception of inadequate distribution of benefits, that's another reason for withdrawal. Other examples are misalignment of goals of a particular organization participant with the ecosystem goals. They literally may be heading in different directions. Lack of transparency around the motivations of participants could actually cause a failure of a loss of trust, which warrants participants withdrawing their participation. They may not trust the motivations of other participants, including governing parties. They may be fearful of submitting information or data or value into the ecosystem because they feel that will be abused or taken advantage of by other parties to the ecosystem. And then finally, particularly where information had to be submitted into an ecosystem, there was a concern about the privacy and the confidentiality of that information, particularly where other participants are competitors of a participant. And so if there's no means of ensuring the confidentiality or the security of information being shared and having confidence that it won't be used against a participant, then that lack or that concern about privacy and confidentiality is another reason for a participant to withdraw participation. And if enough of them do it, again, ultimately leading to the failure of the ecosystem. So these were sort of a series of interesting findings in which we've now incorporated into sort of design around how do you actually design an ecosystem collaboration to optimize and reduce the possibility of these failure cases being in existence. So what I've got here now are 3 separate ecosystem collaboration governance designs which we developed as part of this research. And they move from centralized all the way to the right there, which we call liquid, which you'll obviously be very familiar with, highly decentralized. But if I start on the left, this is the concept that we described as an alpha governance model, where you have many participants in an ecosystem, but fundamentally there is one key participant, the alpha, who actually purportedly governs and drives the overall health and activity of the ecosystem. So it's essentially a single decision maker. It's based on a leader concept of a leading governing body. And for success, you normally have to require that governing body to be very clear and transparent around the distribution of benefits. And this is really important so that the other participants feel that that governing alpha is not attracting all of the benefits at their expense. It's also very important that that alpha is visibly investing in the infrastructure of the ecosystem. Participants see an alpha governing body is contributing to new capability, investing in the maintenance of an ecosystem and the health of the ecosystem, then all of those factors contribute to the longevity and the success of that ecosystem. We see these ecosystems quite prevalent in technology platforms. In fact, we did a case study on Salesforce and their App Exchange platform and demonstrated how Salesforce is reasonably well regarded for how it invests in the platform and continually innovates on that platform to the benefit of participants. And so that's the alpha model. It's centralized governance. It can fall foul of the failure cases we just looked at previously. So it's really important that the governing alpha goes out of its way to distribute benefits and demonstrate investment in the platform and in the ecosystem itself to keep the maintenance of the trust of participants on an ongoing basis. The next model, which we're finding is actually increasingly popular in ecosystems where there's at least a small number, if not a larger number, of relatively powerful parties. In this case, we call it representative governance. And the concept here is that main parties, not necessarily all parties, but at least a significant number of powerful parties, each collectively nominate and endorse a governing body to be established that represents their interests. And so it could be a shared committee, for instance, which includes participant members, or it could be a new institution or an organization that's set up to specifically represent the interests of a diverse set of ecosystem participants. And so the governing authority governs on behalf of all participants. Important here, we talked about, is the ability to deal with contention and disagreement, because now you've got more parties represented in the central governing decisions. And so contention management is really key. Importantly, also, it's critical to actually have a social contract in place, and so that the parties who are represented by that governing authority have an agreement socially around how they're going to behave and what role they're going to play as part of that governing authority. And so these were key reasons for success, and addressed again some of the failure cases that could otherwise undermine the longevity of an ecosystem. And then finally, the third viable governing body model that we saw was one that was really coming out of the Web3 community in particular, and we called this the liquid governance model. And this is where we have a very large number of participants who achieve consensus using some kind of consensus rules. Typically, there is a technology dependency here on some kind of blockchain-based voting, could be a DAO-based system, but essentially a Web3 distributed community protocol was a technical dependency required for sort of scalable liquid governance. But in terms of success factors, a few interesting concepts were apparent in the research. One is the very important prevalence of efficient value distribution. Because there's a lot of participants, it's really important to be able to efficiently distribute value and benefits across participants. If it's inefficient, then there's a risk that participants don't feel that they're actually receiving adequate compensation for participation. Another issue that has to be addressed in the design of this governance, and it's also relevant for representative governance, is a crisis resolution modality. So the ability to make decisions in a hurry during a crisis. Typically, decision-making in these more distributed governance models takes longer because there's more parties to organize and coordinate. And so there needs to be the ability to switch into a crisis resolution mode when necessary. In those cases, sometimes we see a collapsing of governance. And rather than going to the right, you may see at least a short-term collapse down to a more centralized governing modality until the crisis is passed. Some interesting concepts that came from the discussion too is this concept of minimal viable democracy. I'll thank Max for that contribution. The concept that you don't need every single participant in the community to vote or participate in governance, but you just need just enough. And so that adds an efficiency dividend to the governance. It also means that you generally want those members of the community who are experts on the issue that is being governed to lean in and participate in the governance. And you want those who are not experts to rely on the reputation of others who are participating in the governance as experts. And so if you can get those permutations and configurations right, you can have a sustainable liquid governance model across a highly distributed community. So this was really the heart of the research findings, is how to design different governance scenarios to optimize for the failure cases and the success measures needed to get successful ecosystem governance on in a sustainable fashion. So key findings of the research: importance of transparency of decision-making and actions to build trust and consensus over time, the criticality of participation, whether it's representative or liquid, in decision-making in order to access resources, but also expertise so you have higher quality decisions. And then very importantly, the criticality of distributing costs across the participants in a fair manner, but even more importantly, the perception and the reality of distributing benefits equitably across the participants so they feel like there is an adequate compensation for sustained participation in the ecosystem. So now I'm going to get to the very last part of the discussion. And now this is the extension of the research that we're currently building. So we've looked at the governance of ecosystems and how there are different modalities for governing ecosystems. The current research project we're doing is extending this to look at the resilience of those ecosystems. And I wanted to draw your attention to the subline and the heading there. what are key elements for ecosystem resilience? The key finding from our research is that ecosystems lack certain organizational levers that exist in companies or institutions, and so has to compensate for this lack with other measures. So some of the things that an ecosystem lacks that do exist in an organization or an institution is they lack hierarchical authority. There's no boss typically in an ecosystem that can order all of the participants to act in a certain way. And so there has to be less reliance on hierarchical authority. The other thing that is lacking in ecosystem is controlled systems. Within an organization, an institution, you typically have much more control over the systems and the flow of information. But the moment you get into an ecosystem, you're reliant on information being shared between organizations, individuals who do not have the same shared infrastructure. And so you have less reliance on controlled systems. And so because you lack hierarchical authority, and because you lack controlled systems, you have to rely on other compensating measures. And these were some of the key factors that the researchers identified. The first that I identify is critical intelligence feedback loops. We see we've used the term UDA, which has come from US Air Force contribution into the research, which is this opportunity to observe, orient, decide, and act across an ecosystem. Obviously, initially from military context, but the idea being that you want to very quickly, as a pilot, contextualize the war theater and be able to understand a threat and decide and then make an action as quickly as possible. So first you want to close the loop, and then you want to accelerate the loop. And so in a digital ecosystem in particular, you want to be able to get intelligence from multiple participants, both inside and outside the ecosystem. You want to be able to orient threats and opportunities, make decisions, and then act on those as quickly as possible. And so consciously architecting feedback loops across participants is really important, and to compensate for the lack of controlled systems that otherwise exist in an ecosystem. This is particularly important when you have a high threat environment. And so the UDA feedback loop is particularly important to engineer and then sustain in order to be able to respond to rapidly evolving threats. A few other key measures I'll just highlight here is the importance of building trust, because inherently there is very little trust or no trust in an ecosystem. And so there has to be conscious efforts and mechanisms established to build trust between parties where trust is required. And so that has to be a conscious design consideration for not just the setup of an ecosystem, but its ongoing maintenance. Critical to have appropriate industry and government collaborations, and this could include regulators, but this could include all aspects of government, including defense, health, education. In this case, in the context it was developed here, was in the context of cybersecurity, to make sure that certain threat information that government has unique access to can be shared with industry in an opportune basis. I've already talked about the criticality of cost and value distribution, and this needs to be engineered into an ecosystem design to make sure that cost and value can be captured and then parsed and distributed equitably across participants. I've already talked about the criticality of having a crisis resolution modality. Typically, ecosystems can operate quite slowly, change can happen over time, but there needs to be the ability to switch into a crisis resolution mode when threats are urgent and have to be resolved rapidly. And then very importantly, and this came up from some research we did with NASA when they were looking at their private and public and collaboration that's now occurring, is this importance of orchestrating functions. There are some things where it just helps to have a coordinator or a designated individual or institution or organization that has a role that just adds efficiency and coordination of information, activity, assets across an ecosystem, which otherwise would be very difficult to negotiate multilaterally. And so depending on the nature of the ecosystem, it would be valuable to say, are there certain functions which would benefit from orchestration, and declaring someone accountable for that orchestration and seeking their endorsement by the bulk of the participating ecosystem members. The last thing I'm going to show you, one of the last things, is just this cascading view of where enterprise resilience sits in relationship to ecosystem resilience. What I've got here is just the layers of capability and discipline that are needed to collectively build system resilience, expand it to functional resilience, and then ultimately have enterprise resilience. And what I wanted to do here is articulate what in addition is needed to achieve ecosystem resilience at a whole of network, whole of ecosystem level. Again, the mechanisms such as feedback OODA loops are quite different to what's required at the lower levels of resilience hierarchy. And then very finally, the last slide that I have is on the left here. I've sort of laid out the typical progression you have to try to build up collective organizational resilience and world-class resilience at an organizational level. But I've tried to create a clear mark here to identify that at an ecosystem level, you need more of an orchestration function. And they're very specific things like looking after systemic risk, benefit distribution, trust curation, which is not typically done at an organizational level. And so it's really important that if you are an organization that has an accountability for a broader ecosystem health or sustainability, that you think about adding some extra dimensions to your focus, because your efforts or even your excellence in organizational resilience is not going to otherwise achieve those outcomes for the ecosystem. So we've covered a lot. I've just got some links here to our MIT research. You can go to the MIT CISR Center for Information Systems and actually see some of the deeper analysis of the research that I've shared with you today. I'm very happy if anyone wants to reach out or even ask any questions now. So Serge and Max, I guess we're wrapping up. If there's time for any questions, very happy to take them.
Yes, thank you so much for the great presentation. Here is the question from Max. Could you share more on how the crisis resolution modality could work, or with some examples?
Sure. We've thought about this from a financial sector perspective, Max. There may be a payments outage which actually warrants taking off a certain participant off the network. So if there's a regulator involved, they may say, actually, we're having an issue caused by a participant in a financial payment chain. And while they are on the network, they are contributing to operational failures for other participants. And so we'll execute a kill switch and take them off the network. So that could be an example where maybe the governing body or a subset of the governing body, you may have a crisis team that is appointed, can have the authority to literally withdraw participants from the ecosystem in a digital context. So that's just one example.
Well, that's very interesting. I have an assumption that there is a lot of game theory involved in this study, and I wanted to ask, where can we review the full version? Maybe it is published somewhere.
Yes, I've put the link here actually on this page. You can see the CISR stands for Center for Information Systems Research at MIT.edu. And just on the bottom, you can go to Research Library, and you can research. Yes. You can research for these two projects: designing ecosystem governance to grow value and approaches to ecosystem governance, and that will reveal a little bit more about the information we shared today. Some of the research, Sergi, that I presented hasn't yet been published, so it's still in-flight research.
Well, that would be very interesting. If you can let us know where we can follow you and follow the publishing of your research findings, that would be helpful for us.
Yeah, great. I'm pretty boring. You can just follow me on LinkedIn. And obviously, I've shared my email at the beginning of the research, so you can just get in touch directly as well.
Sounds great. Yeah, that's so. Let's see if we have any other questions. It doesn't seem so. Well, in that case, thank you so much for being with us, and yeah, we definitely will be following up with you. So thank you. It was very insightful presentation.
Thanks, Serge. Thanks, Max. Thanks all.
Yeah, have a great day. Thank you.
You too.
Bye-bye.